Okay, as an example, let's suppose that t of xy equals 3x plus 4y. Okay? Now, what are our vectors v1 and v2 going to be? Well, t applies to ordered pairs, so we have to have vectors with ordered pairs. Okay? So v1 would have to be a pair of numbers, an ordered pair of numbers. Well, it makes sense to call that x1, y1. It's an xy, but it's got a subscript. Okay? You could call it something else. You could call it AB if you wanted to. But this notation with the subscripts is a little more closely related here, and it makes the task of keeping track of the algebra a little simpler. V2 is x2, y2. Okay, so x1, y1, x2, y2 could be any real numbers, but there's your v1, there's your v2. And then we need a vector v, so we're just going to call v xy. Don't have to be imaginative about that. Ouch. Okay, so we want to show that t of v1 plus v2 equals t of v1 plus t of v2. So we write down what t of v1 plus v2 would be. Well, t of v1 plus v2 equals what? Well, v1 plus v2 is clearly x1 plus x2, y1 plus y2. And what does t do to x1 plus x2, y1 plus y2? Takes 3 times the first one, which is the x1 plus x2, and adds that to 4 times the second one, okay, which is the y1 plus y2. And then we do a little algebra, and I skipped a step here, but you can see how to rearrange it. You can distribute, and then you can regroup the x1 and y1 and the x2 and the y2, but you see that what we're going to get is 3x1 plus 4y1. See, we have a 3x1 and a 4y1, and then we have a 3x2 and a 4y2. So we have 3x1 plus 4y1 added to 3x2 plus 4y2. And I say that's equal to tv1 plus tv2. Now, I left it at that, and I expect you to plug in v1 alone into this rule. That means you're going to apply the transformation to x1, y1. What are you going to get? You're going to get 3x1 plus 4y1. Then plug in v2, which is x2, y2, and you're going to get 3x2 plus 4y2. And when you add these two, you're going to get this plus this. But you should write that out. People often understand what's going on. They understand why it's true, but they have trouble writing it out. Well, sometimes you don't even see the point to why you write it out. Well, you write it out so that you get it written out and you can check and make doubly sure that you understand it. But writing it out is a hump that everybody has to get over. So that's what we would do for this function. And we would see that this is equal. Now there's also the t of cv equals ct of v, and you simply write that out for v equals xy. Figure out what cv would be. Well, that's cx cy, isn't it? And what does t do to cx cy? Well, it takes the first number here, multiplies it by 3, second number, and multiplies it by 4, so you're going to get what you get. And then tv is just 3x plus 4y. You multiply that quantity by c and see if it agrees with what you have here. It will, and this transformation is going to be linear. Okay? Now we have another example, and this one's going to turn out not to be linear, just to contrast linearity with nonlinearity. In this case, instead of some kind of a sum, I just say t of xy equals x times y. That's a very simple transformation, very simple to understand what it does. It just multiplies this number by this number. Now, is that linear, though? Okay, it's simple enough, but is it linear? Well, V1 is, we're still going to use the same symbols for V1 and V2 that we used over here. So T of V1 is just this number times this number, x1 times y1. And T of V2, since V2 is x2, y2, that's equal to the product x2, y2. Something got smudged here. It did not smudge, it kind of got erased a little bit. Or maybe it just didn't get written very clearly. The board's a little wobbly over there. Okay, Well, anyhow, that's our T of V1 and our T of V2 that we would put into this equation to test whether at least this aspect of linearity is supported, is valid for this transformation. Then we got to do T of V1 plus V2. Okay. So what's V1 plus V2? Well, we saw what it was here, right? It's the same thing. So that's T of x1 plus x2, y1 plus y2. Because clearly V1 plus V2, if you add it up, gives you this. And then the transformation takes this times this, because that's the rule for the transformation. First number times second number. So we get x1 plus x2 multiplied by y1 plus y2. Well, yeah, we want to expand that so we can compare it with what we get when we add T of V1 to T of V2. So we multiply this out and we get, just expanding binomial, I would use the distributive law rather than that F word thing. And you get x1, y1 plus x2, y2 plus x2, y1 plus x2, y2, as you can easily verify. But, now my circle's kind of running through here, but I haven't crossed anything out. But I say then, but T of V1 plus T of V2 is what? Okay, now again, T of V1 plus V2 is what's on the left-hand side. That has to equal what's on the right-hand side, and what's on the right-hand side is T of V1 plus T of V2. And that's, well, x1, y1 plus x2, y2. And these two are equal. So this transformation is not linear. This one is, this one isn't. Now, there are several problems that are assigned where you explore different types of rules to see what's linear and what isn't, so you get a feel for what linearity means.